All right, and this is going to be our lecture for classes. So to start off with this, we're going to think about classes as containers. So essentially, if we have a dog, we can take my dog, for example. His name is Chewy, he's 8 years old, and he has white hair. Therefore, we can also make another dog. His name is Joe, he's 10, and he has black hair. So now we can assign each of these to their own specific variables. And now we can reference Chewy and we can reference Joe, and we can reference all of the different things that either of them contain. So the way this would look in Java is having a public class named dog with our string name, which would be the type. We just need a string. We don't need anything crazy. Integer for the age and a string for the hair color. The reason I picked integer for age is because in this specific scenario, I don't want to have to deal with floats as ages. So moving on to constructors, essentially this is how we would make a dog class. So inside of our class, if we had class dog, and we had all of our variables, this would go right in here. So essentially what we can do is we can make one with no parameters. So that would be like if we just said dog Joe is equal to dog, and this should have a new before it. A new dog, right? So this would construct a dog with this set of parameters. So we're able to reference this dog's name, this dog's age, and this dog's hair color. Then if we wanted to instead make a dog Chewy is equal to new dog, and then we could put in the parameters. So like we would have this name, so Chewy, comma, and then our age, which is going to be 8. Then we have hair color, which is going to be white. So there we go. Now we can reference that, and we can construct different things and construct different dogs using this class. One other cool thing with this is this keyword right here. This keyword refers to the current instance of the class. So for instance, with Joe, the keyword would then point to Joe. But for Chewy, this keyword, when used inside the dog class, inside of the Chewy instance, will point to the same Chewy dog. So that's one of those little confusing concepts that kind of just got to experiment with, but you'll figure it out eventually. But just know it points to the current instance and it refers to the current instance. So then we can assign to the classes. So we can see that, hey, we have a underscore name, which is going to be Joe or Chewy for their respective dog classes. But we have the type, then the name, then the new keyword, which makes a new instance of the class, and then the class with our 3 parameters. And we can have as many parameters as we want and as many parameters as the constructor takes. So then if we want to add in methods, we can add this bark method. So what this will do is it'll just print out that the name says hi. And again, we're using this as an instance, this dog's name, and we're just using a format string, so we're telling it to plug it in right there. So we're telling it, hey, this name says hi. Another more conventional way to do it that people like better is string concatenation. So we just plug the 2 strings in and we add them together. It'll do the exact same thing, just one may be easier for you to understand than the other. So for the next one, we're going to use methods. We're going to actually use these methods. So using how we defined it later as dog Chewy is equal to new dog with our parameters, right? Then we can say chewy.bark, and it will print out Chewy says hi. Or for Joe, it'll print out Joe says hi. So this is one of the ways we can actually make classes work better. And essentially what this will do is it helps us to make stuff more manageable and make our class sizes smaller. So if we make another method, we'll make an increment age, and I'd like you to predict what this one will do. But essentially what it does is it takes the current age and adds one, and then it returns the current age. So then this is the result if we add one to the age of both our Chewy and Joe classes that we defined a couple minutes ago. So next, we're going to go through inheritance real quick. This is one of the topics that is a little bit more confusing in object-oriented programming because it's not necessarily intuitive. But essentially, we could have an animal class, and we know every animal is going to have a string name and an integer age, and we need a way to increment their age, and we need a way for them to make sound. So we can define all those variables and methods, and then we can make our dog class extend the animal class. So that means we can use all of the methods that are in the dog class in the animal class, right? So all of these different methods we can use in the dog class, and they'll have all this predefined behavior. So then for dog, we can define our make sound as it's just going to bark. So for the next part of this, we can make a generic animal where instead what it'll do here is when we say generic dog.make sound, it's actually of type animal. So what's it going to do then? It's going to say generic says hi, which is what we defined in our dog class. Because for polymorphism, it is a dog. Generally, you should not use inheritance to this level because polymorphism, aka the way all of this goes on and like changes, gets really, really funky really quickly. So then if we say generic dog.increment age, it's going to give us 101. So then for making this an abstract class, essentially abstract just means we aren't going to define this. So we no longer have a default implementation of make sound. We do have a default implementation of increment age. So in the dog class, we can use this at override to override our abstract method for make sound and create one for the dog class. So then let's make a car class. So if we make an abstract car vehicle, we can make our, we'll have a color, we'll have a model, we'll have a type, we'll have a year, and we'll have a start and stop method. So then if we make a car class, this is what I think it would look like. And obviously can be different for everyone else. But if we make a car extend vehicle, well, we know that a car needs a throttle. We know that the type is always going to be car, so we can always put that in. And then we will need to know these other three. For start, we're just going to put the throttle at 1, again, overriding it. And we'll override the stop, putting the throttle at 0. So then we can also add methods, even though we're extending it as well. So you can see right here, I've added a lock function, which will just lock the car. So for the relationship to FTC, linear op mode is always extended to give us our teleops and autos. However, this is why we need to implement the run op mode, because it is an abstract class. All op modes are going to be extensions of the linear op mode or op mode, which forces the method implementation of run op mode, which also gives you wait for start and those cool methods that tell you what cycle the robot is in. So for some specifiers, we can go through real quick. Public is anything may access this method. So your constructor always needs to be public because it always needs to be able to be accessed. Private is only things in the class may access. So for instance, we can hide this bark method and only show the make sound method. And then our default or no specifier just means that the same file may access that variable. So for a more specific example of a class for FTC, we can define a circle which will have a radius and a center. And then we can we'll make a constructor that takes these 2 points, these 2 variables, and we'll implement those. And then we can have a circumference, we can have an area method, we could have like an in method where we would do bool in, and then we could throw in another point under other, and then we could define logic to tell us if our specific other point is within the circle. So that's going to be it for that. I hope this was informative, but thanks for watching.